people that is able to do software development on contract for this. Or there are many ways to go about that, but it's recognizing that that is a problem, that you cannot just make a device and hope that, make a device and an SDK and libraries and patterns and guidelines and hope that people just jump on it. Is like, no, we are way back. We need to take people by the hand and really build these apps for them.
And like on the hardware side, the questions, like, do you think if only we had a wider field of view, if only the form factor was smaller, if only, I don't know, you could use your hands, freely and to interact with objects in the real world, if only we had 5G, like, is there like a main if only that you think that if we get there, then that will make the big difference?
No. So you remember where cell phones were a suitcase like this, and people would actually carry them? The reason why they did that, and they could have wished, if they were smaller, or if they, no, the reason why they did this is because there was enough value in having a phone with you all of the time that it would justify you carrying that suitcase. So headsets right now are very big, and they don't have a great field of view, they don't have a lot of resolution, no. But we haven't found, or we are starting to find, who are those people that it doesn't matter how ugly, bulky, low resolution, small field of view it is, they are gonna say, I need this. So, no. And we need to find those people because they're the ones that are gonna pay the high bills, that is gonna finance the next generation of smaller and nicer looking devices.
So how far are we from having these small form factor, beautiful devices?
How far are we? 10 years. I don't know, I'm very pessimist. I spent a lot of time in Lenovo studying displays. Every time I got excited about whatever new invention, I tried it and it was a disappointment. So, and whatever has come out since then, it's not been much better. So I do think there are some fundamental physics challenges. That is the thing, right? Like when you think about Moore's law, and then technology is moving so fast. Look at Moore's law. In 2 years, we're gonna have headsets. No, well, display technology doesn't move in that pace. It's about physics, and the laws of physics don't change, right? And there is a lot of, before we arrive to a display technology that is gonna allow that, and to a battery technology that's going to allow that, and to a processor design, and we're reaching the sort of like a climax in Moore's law that is gonna allow that device, it's gonna, it's not gonna move fast like that. It's gonna move much slower, and I would say between 5 to 10 years. Yeah, we could win.
Rena, do you have some thoughts?
I'm not worried about. I'm not worried about the hardware so much because I feel like it'll get there eventually. Like it's a matter of time, and I think there are people working on this problem. So I try not to concern myself with that too much. But I think from a design point of view, there's so many challenges, and I don't know if people are figuring them out. Right? I mean, on the one hand, there's the issue that Juan brought up earlier of just the interaction patterns aren't there. We don't have things to draw upon the way you do with web or mobile design. You're basically inventing it as you go, and there's a lot of trial and error in that process of like coming up with something and like seeing if people can figure it out and if it's efficient. If you're gesturing, well, that can get exhausting, right? Like depending on what you're doing, like you don't want people waving their arms around all day. And so, there's that on one hand. And then, I think like another big challenge that we ran into from a design perspective was dealing with color in AR. So, when you work with data visualization, color is important, right? Because there's meaning encoded in the color, right? Like your data like is, categorized, right? And so that became a real challenge as far as accessibility goes, because obviously you want your design products to be accessible to people, and a lot of people are colorblind. And it turns out there's not just one kind of color blindness, but many kinds of color blindness. And you know, when you're designing for web or mobile, there's ways around that, right? There are color, like accessibility, sort of friendly color palettes that you can come up with. But you know, a big part of getting color to work is contrast. So like how the color works in relation to the backgrounds that it's against. So if you have a dark background or a light background, you need to make sure the contrast is good. Now, when you're in AR, there is no background, right? Like your background is the room that you're in, and the room could be anything. It could be white, it could be black, it could be full of stuff that's going to make things really hard to look at. It could be night, it could be day, and so things like lighting really affect how you see the visualization. And then the way the objects are rendered in AR, it's different, right? Like, so if you're looking at something in a HoloLens, which is like a holographic display, that's different than looking at something on a mobile device, which has a different kind of way of projecting an image. So that became like a huge challenge for us. We sort of had to come up with like artificial ways of getting around it in terms of sort of adding some backgrounds and opacities and things like that. And it, you know, it also helped, sort of was a contributing factor in also exploring VR as well, where you don't necessarily have quite the same challenge, right? So I think there's like a lot of design challenges as well that I really want to see sort of resolved and overcome as well, because I do feel like the hardware is going to get there eventually.
But I'm so happy you mentioned the color thing. That there's a paper by a certain Incapié Ramos and no, I literally spent about a year studying that problem, and it's a very important problem in AR. And this is the thing. It is a problem that is a fundamental part of headsets, and I don't think there is a way to fix it. I don't think there is there will be a new generation of AR headsets that are not going to have that problem. Rather, we need to find design approaches to solving that problem. We can talk later.
Yeah, I spent a lot of time pulling my hair out of this as well.
Yeah, although I think that, for example, having blacks in AR...
There is no black,
There
right?
is no black, but having black in AR is something that is going to make a difference. Being...
I don't think
like,
that's going to happen. I don't think
like
it's
environmentally
physically possible
I don't
to
know,
have black.
like, I don't know, magically, because I don't know.
No, that's not true. Like there's physics, and you can't beat physics.
And being environmentally aware, being able to be aware of the lighting out, you know, outside, being able to cast shadows. Like there are things that can be done to help with design that I know that is not, like, we're not there, but definitely.
Yeah, I mean, I think exactly the context, right, of use is a huge challenge, because like as a designer, you don't know where people are necessarily when they're using your product. I mean, in certain circumstances, right, if the product is designed to be like helping you repair a piece of equipment, like you can kind of have a sense of where they are. But yeah, a lot of times you just don't know with these where someone is, what the environment is like. And when the environment is such a huge part of what people are seeing when they're interacting with your AR objects, then yeah, it's a big concern and a big challenge.
Yeah, and I think we also talked a little bit about it before, having some kind of like depth signals, right? Like knowing that something is behind something or something is in front of something, which is very trivial for us to look around us and understand what's behind what. But when we're talking about augmented objects, then that's not necessarily the case, and that is really difficult for users to understand the augmented scene.
Yeah, I mean, we definitely faced that challenge when we were doing that the Wi-Fi signal visualizations that I was telling you about earlier, and it was that issue of occlusion. So whether the object is like in front of, you know, a pillar or behind a pillar. Was a big challenge. And yeah, I remember at the time we were sort of like, well, we could spend a lot of development effort like fixing this because it is a solvable problem, but we'll just kind of wait till, like, you know, the next version of AR kit comes out and fixes it and prioritize some other problems that, you know, we kind of need to do instead. So yeah, there's always things like that, and I think, yeah, that spatial sense of like where something is versus size often comes into play as well. Like, so is something small because it's far away, or is it something small because it's small, right? And so for things like visualization and data visualization, that was definitely a consideration as well.
Okay, and then for a young designer working in 2D UX UI design that once really is interested in getting into augmented reality and understanding how to work in this field, what are your suggestions? What should they be learning? What kind of skills they should be developing? Like how does one progress from being a 2D UX UI designer to AR?
I don't know that there's an easy answer to that question. I think having experience in other things is never bad. Like having that multidisciplinary background can be helpful, just because, like I said, it is a space where there's a lot of invention that has to happen, and a lot of creativity and a lot of problem solving. And I think if you come from any kind of other background or different space even, it can be helpful in just like helping you look at things a little bit differently or with a fresh perspective. And I think being the kind of person that is like okay with failing a lot and just like trying things and sort of having to butt your head up against a brick wall, honestly, like there is a lot of that, right? Like there's gonna be frustration, so you have to like be the kind of person that's okay with that. But then, you know, beyond that, like, I mean, certainly there are lots of tools, and, you know, you can always sort of just start learning. I mean, certainly there's tutorials on there for things like Unity or Unreal or, you know, whichever sort of system you might be interested in learning. But I think also like trying things out, right? Like just download some AR apps, play with, you know, AR and VR headsets. I think just getting familiar with those things and seeing what the interaction is like is like a big part of sort of just developing the familiarity with the space.
Yes, I agree. The beautiful thing is that this is just being created. The rules have not been written. Join, help write those rules. It's all to be done.
These are such great words to end the panel with and open it to you to ask questions.
I'm wondering if Google Material Design is working with your team at all, or if there's any sort of design system that you're thinking about.
Yes, material design is a very 2D oriented design language. So we are not necessarily using the same, or you know, there are things there that literally directly translate into AR. There is a lot of the AR work at Google has been done by the Google Lens team, and who's been using Google Lens here? Okay, so I invite everyone to try it. So there are some. Google Lens has about, I don't know, I think it's like 7 or 8 things that it can do, and there is a pattern that's starting to merge. So if you look at the history of material design was something that was created after many years of making apps and websites, and then they kind of like got together and started to say like, oh, let's leverage the best things that we have all come up with. So there is. We are trying to do something similar to that without rushing into it. So in material design, they came to that after many years of apps that were used by millions of people every day. We have Lens, and you know, Lens is just emerging. We have what we are doing in Google Maps, and you know, I think we are having something like very good, like 100,000 daily users, which is a big success. We are yet to see if it is like a blip of early adopter kind of like rush into trying it, but it's very good. But anyway, so there will be something like that. We just let me say, me personally, I don't want to rush into that, and when I'm asked about it, I kind of like put the brake a little bit and say like, no, 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 I think there is a lot of discovery that needs to happen yet. Let's not rush into that. So, but, you know, you can imagine 5 years there will be that. Yeah.
I go first. Okay. So as you mentioned, technology is growing fast, and also the RVR is has a limited frame. But as we all know, safety is still should be the most important thing. We all read the news that people playing the Pokemon, and they face in like hazard environment. So during the designing process, what's the most when you're facing it? What's the things that you're focused on when during this process? Whether it's like preventing what is specific focal point that can avoid any risk, or whether it's using the headsets, like it might cause like nausea or like vomiting or like any potential risk.
You want to go at it?
What's like you mentioned it's a challenge, like very challenging, but is there things that
Yeah, so you're talking about like from a safety perspective? Yeah, I mean, I guess, it's good practice to avoid putting things behind someone, right? So like you don't necessarily want them like spinning around and getting disoriented, or, you don't want them having to like walk backwards, right? Or take steps back too much, so you kind of want things maybe arranged in a certain way so that it's not going to like cause them to do anything dangerous, particularly if it's like VR, right? And you're just completely out of your environment. So you kind of want to limit that movement, and you can obviously use things like teleportation as well to sort of like prevent people from having to like walk big distances as well. So there's that. I mean, the nausea, I don't know. I feel like that's like companies are trying to like overcome that a little bit. That's probably more from a hardware perspective. I don't know. Did you have thoughts on that?
Yeah. So let me answer the first part in terms of AR. Yes, the Pokemon Go example that you mentioned is a good example of sort of like unsafe behavior. We're aware of that, and that's why the type of AR we are doing explicitly tells the user not to walk. And when we detect that the user starts to walk with their phone like this, we stop the augmentation. I would say like, no, you're not supposed to walk. Especially because there is a phenomenon called display blindness, where you get focused on something and then you don't see the other things, and that's particularly acute on handheld devices. I'm not sure why, but what happens is that people focus on the augmentation when they see it, because it takes a while before they see it, and then they see it and they only see that. So if they start working like this, they very quickly are going to fall into a manhole or run over by a car. So we are very, very explicit that's one of our design principles, no walking. And now to talk about the nausea thing, I think nausea in VR is a really difficult problem, because even if we get like these really good displays that completely trick the eye into thinking you are there, the main source of the nausea is because your body is not moving physically at in the same manner that it is moving in the virtual world. And so there is no display that's gonna fix that. I was recently at a conference where there were some people giving out a special type of candy that would prevent that. I'm not sure how scientific that is, but for some people it seems to work. It has ginger. That is a big problem for VR, and it might be that is the way that defines what type of experiences will be appropriate for VR. Things where you don't have to move a lot. We'll see.
This might be more of a hardware question, but is there a point where guys envision moving between in the same sort of headset device, moving between AR and VR, or are they separate disciplines? Yeah.
Yeah, I mean, there are definitely headsets that exist that do both. And I could definitely envision that being useful for us because, one of the reasons we started with AR was because it's for enterprise and because it's people using it in an office environment, we really wanted to keep people grounded in their space, right? We didn't want our users to be sort of like wearing VR headsets and stumbling around the office while they're trying to find insights and then show it to their executives. And so that was why we started out with AR. So then you can kind of move seamlessly between, like looking at your notebooks on your computer and the sort of model building there, and then looking at things in the AR space. And then, as I said, we came across some of these challenges relating to color and display, and we thought, let's try VR and see how that works instead. So I could definitely see there being a benefit of being able to switch between both in like this kind of enterprise setting.
I can also answer you. So what you're talking about is called pass-through AR, and actually it's going both ways now. It's going from like AR headsets using these cameras that are usually used for VR headsets to kind of understand the surrounding. So the AR is using it, and then VR is using it as well. So it's going both ways. There's actually a lot of benefit to using pass-through AR, mostly because you can do, and as Juan knows, you can do a lot with a camera view. And at the moment, I would say it's even a little bit easier to use the camera view over the real world view and try to place holograms, because of the many challenges that we have with our eyesight and with the placing the holograms in space. So in the past, I think VR and AR were mostly looked at as like relatives, as like somehow close relatives, but I think they're getting closer to each other.
I don't know. I disagree. I think I think they are at the end, at two opposite ends of this AR, or how do I say this? Like a good AR device, if you are going to make the best AR device that you could, you necessarily do sacrifices, or you'll have to make design decisions that will mean that is not good for VR. And if you make a really good VR device, it's gonna be a very crappy AR experience. So I think long term, those paths are going to separate very markedly. Is there a middle point for a device that can do both? Yeah, sure. Like an SUV is not a good automobile, but it's not a good pickup truck either. So, sure.
I don't know. If you look, for example, at the Quest.
Yeah, for example.
And but like the Oculus Quest. It's a good device, but and I think they are doing some type of like AR in it as well, like being able to view the world around you.
Sure, and there is a version of that. Of course, you can see it, but like when you are without a VR headset, you can move your eyes like this, and then it's gonna slightly change, even very, very slightly, your field of view. There is no way you can replicate that behavior in a pass-through VR headset, and therefore the experience will always be inferior. You know what I'm saying?
Yeah, because
that's just an example, right?
I think that right now a lot of the problems that we're seeing with AR headsets, and I'm sorry, like I worked at Meta before, so
go
yeah. A lot of the problems that we're seeing with AR headsets is the is the problems with what you're seeing versus what the system is seeing,
Yes.
and understanding that delta between
Yes.
what the cameras and what the sensors are seeing. If you know where your hand is inside your field of view, and that's like using either the sensors or the cameras, or understanding that the field of view that you are seeing with your eyes is not the field of view that the headset is seeing. There's a lot of a problem with that. And once, and the good things about pass-through AR is that there is no discrepancy, right? Because what you know that what you're seeing is what the camera is seeing. And you have that,
Sure.
that like immediate feedback on your world.
Sure. But is that the AR headset that we all want to have?
Probably not.
Okay.
But none of the AR headsets that are currently out there are not the headsets that we've been dreaming of.
Yes.
And all I'm saying is, and it's going back to your question, maybe I'm asking a question. It's not that like I know or I have any insight, but perhaps the AR headset that we are dreaming of is a headset that has multiple cameras on it, and we can see 360, and like the cameras can see all over, and it's not using just our eyesight, but using what the enhancement that can be created through that. I don't know. I'm asking questions. I don't know if that's the way, but I'm just not saying that it isn't, or that it's a bad experience, or that it's not. This is not where it's going, because I don't know, and I don't have the answers for that.
Okay.
Yeah.
I have two questions. You mentioned that you read a paper on a white paper on colorblind.
Oh no, on color perception in AR headsets. Yeah.
Do you have the name of that? Of the author?
It's Juan. Huh?
You wrote it.
Yes.
I thought, okay.
Yeah.
And the other question is, does IBM and Google, do they share their findings? I know this is very open.
Yeah. Yeah, sure. And I think it's just like the example of material design. If you go, you can read a lot about material design and how to do this. I think we will have a version of that at some point. To be honest, internally, things sometimes get done very quickly and very scrappy, and there is a lot of insight that is not written anywhere. It's just in the people. So before they release something that they are comfortable, making sure that it is indeed what they mean to say, there will be some time, yes. But yeah, slowly. Yeah.
I guess I'll follow.
Good.
In designing for AR, VR, are there ethical considerations that your team kind of taking, or maybe things that you discovered that are not so obvious?
Ethical, like Black Mirror type of.
I don't know. I'm asking because I don't know.
Well, yes. There are many aspects to the ethics of AR and VR and AI, but I don't want to go there. But I can tell you about something very specific, which is accessibility in this space is really something that we have no idea about. So that's one of actually the things that we are working on right now is, we made this really nice AR walking navigation feature for Google Maps, but we have not yet figured out how do we make it accessible, especially for two types of users that actually are a large portion of Android users, which is low vision and blind people. So the ethical thing the easiest thing for us to do is just to ignore this and focus and keep moving forward on other features. The ethical thing is to make a little bit of of a hold and go back and start to explore that and start to actually implement that, which is what we are doing, right? But you're right, there are many considerations. One of the other things that, no, I'm not supposed to say that, but when you do image processing, and you share this data with the online servers that do another part of the equation of what's going on, we are doing a very hard work in removing everything that could be that could compromise privacy. So you might know that we remove faces. Right now we limit whatever we do inside people's homes to not work online, so that data never leaves the device, and a series of things like that. So and you will see more of that coming up.
Yeah, I was just going to add that I think the ethics issue that probably concerns. The ethics issue that I think concerns me, not necessarily something that has come across in our work specifically, but just with the hardware, as you sort of see the glasses, the headsets becoming more streamlined to look more like sort of regular, like reading glasses or sunglasses, is just that information asymmetry, right? Of like if people are walking around with glasses and they're able to sort of be reading things and sort of using facial recognition and seeing things about you without you knowing that it's happening. I think that there's definitely ethics questions that we're going to have to start thinking through as far as regulation and all of that down the line.
Thank you.
Yeah, I can give you an answer as well.
Yeah, thank you.
So when I worked at Meta, this is a very known use case, and many companies are trying to do that and trying to do remote collaboration. And there are many ways of doing remote collaboration. You can use 3D volumetric capturing, to capture someone's whole body and use that as a hologram and do this kind of collaboration. Or, for example, a lot of companies go down the avatar way. And there are many ways of creating avatars. You can upload a photo of yourself, and then it automatically creates a 3D visualization of your face. You can create avatars using 2D images. There are many ways of doing that. And when we were trying to do that, we were actually using my face for one of the prototypes. And there was something very, very creepy about the fact that someone else can use your face to communicate with other people. And how do you secure that? And